And this is our second example of Newton's second law in 2 dimensions, taking into account connected masses with a ramp in play. And our force of gravity breaks up into 2 components. We did A already in a previous video. This one is going to solve B. So we'll get right to the question, what mass would result in an acceleration of 0.21 meters per second squared down the ramp? So the mass hanging off the side is our counterweight. That's 35 kilograms. M1 is what we're trying to figure out. The acceleration is given. It's down the ramp. That'll be important. Coefficient of friction, 0.23, and the angle, 40 degrees. As always, first step before you do any calculations or even write your variables down, choose your coordinate system. What is positive and what is negative? Let's call that direction the y direction. This is the x. So those are my positive directions. So down the ramp is positive, and perpendicular to the ramp and upwards is positive, downwards perpendicular is negative, and then up the ramp is a negative direction as well. Okay. Similar to what we did in A, it's the exact same setup. You just have to be very careful with the direction that friction is in. In A, friction was down the ramp. In B, the mass is moving down the ramp. Friction is going to be up the ramp. Friction is going to be acting with M2 to counteract the downward motion. And so the only force down the ramp will be gravity. So let's label that. So the only force down the ramp here is gravity. Friction is pulling up. There's our force of friction now. Make that a little bit clearer. And then we've got the force of gravity from the second mass. So that does not break up into components because all of that mass actually acts up the ramp. Even though it's hanging off to the side, it's almost like someone's pulling the mass up the ramp with the same amount of force. Okay, so let's write down our relationship. Newton's second law, net force, which is the sum of all the forces, equals the sum of all the masses that are moving, times the acceleration. The direction of the acceleration, very important. Once again, we're solving for M1. Force is in play, force of gravity from the second mass. We've got the force of friction pulling up the ramp, and we have the force of gravity from mass 1 acting down the ramp in the x direction. That has to equal the sum of each mass times the acceleration. Okay, so let's put our numbers in and describe my equations as I go to save a little bit of time. Force of gravity is going to be acting up the ramp. Force of gravity from the second mass is up the ramp, so that's going to be negative mass times 9.81. Force of friction is acting up the ramp, so it's going to be negative coefficient of friction. Mass of the object, which we're trying to find, times the acceleration of gravity, so that's its force of gravity. Taking into account the ramp, we would multiply by the cosine of the angle. Force of gravity from mass 1 is acting down the ramp, so that's positive, and so that's going to be M1 times 9.81 sine over 40 degrees. And that equals the sum of each masses. So M1 is what we're trying to figure out. M2 is still 35. The acceleration, I'm going to emphasize that it's positive, 0.21, because it's now accelerating down the ramp. So friction is negative, acceleration is positive. In the previous question, it was the other way around. Acceleration was negative, friction was positive. So that was kind of the key to solving this whole problem, is really identifying which direction acceleration and friction is in and being careful with your math. Crunch this through, 35 times 9.81, negative 343.35. Friction, 0.23 times 9.81 times cosine 40, negative 1.73, and then M1's there, plus 9.81 times sine 40. Make sure your calculator's in degrees. 6.31 M1. That has to equal 0.21 M1 plus 14.7, not minus, as we had in part A. So I'm going to put all of my M1s on the left and all of my numbers on the right. It doesn't really matter. So on the left, I've got a negative 1.73 added to 6.31. Then I have to subtract the 0.21 from the right because that's going to go to the other side and become negative. So on the left, I have positive 4.37 M1. On the right, the 343 is going to become positive 343.35, and it's going to add to 14.7, give me 358.05, dividing both sides by 4.37, gives me a mass of 82 kilograms. So I was probably a little more precise with my decimal places, so even though the answer we're supposed to get is around 80, 82 is definitely close enough. It's a matter of rounding and precision. So to make an acceleration down the ramp, you need a very heavy object, very massive object, 82 kilograms.